Hi everyone, welcome to YourPedia Education. This is Chandrasekhar, Faculty of Electrical and Electronics Engineering at YourPedia. See, we all know that BEL notification is out. So this is one of the, I can say, big notification for all of you. So there are more number of vacancies for electronic students, and compared to the previous years, the competition is less. Yes, truly it is, competition is less. And the paper standard, the level of questioning in BEL is also low compared to GATE and other competitive exam. Mostly the questions are one-liner, or there are some questions in which numericals are there, like I can say in subject like network analysis, in the topics like network theorems. Okay, there may be some calculation involved questions. Otherwise, the questions are very easy, right? So there is less competition, more number of posts, and syllabus is also less, and the question paper is easy. This is the right time to catch one of the prestigious job in India, that is BEL, Bharat Electronics Limited, a golden opportunity for all of you electronics engineers, right? And this notification keep coming every year on every year basis, because it previously they used to recruit through GATE. Now this is not through GATE. Okay, once upon a time it was used to recruit through GATE. Now it is not through GATE. This is through written exam, which is an advantage for all of you. Because see, if all PSUs are through GATE, that 1 day 3 hours are going to decide your entire year. Okay, suppose on that day, due to some reason you was unable to perform well in the GATE examination, your I can say your doors for the PSUs is closed for that year. Again, you have to appear for the GATE examination next year. So in 1 year, many things will happen, right? But instead of this, that many PSUs are withdrawing from GATE. They're conducting their own exam. That is one of the positive thing that is happening towards candidates. Okay, so BEL is one of the very good notification. I think all of you who are holding and who are thinking to prepare for PSU must and should prepare for this BEL examination. And YourPedia is one of the biggest, largest, and a great platform for the preparation of exams like BEL, ISRO, DRDO. Okay, we have proven record in giving guidance for these kind of examinations with the results, proven record with results, right? So today in this video, I'm going to take up network analysis, some basics of network analysis. See, subjects like networks, controls, signals, these subjects are procedure oriented subjects. Okay, if you learn concept and the procedure to solve the problem, it is done. That two basics are very, very important, right? So today in this video, I'll teach few basics, and the way I'm going to deal the subject is very different. We are going to learn concept through questions, not just theory. Most of the concepts we will be learning through questions, right? And see, let us see the first of all syllabus. Most of the questions will come from these areas only. The first topic is DC analysis. Yeah, this is very, very important topic. So in this one, we are going to learn all the basics. Then AC analysis, transient analysis, and two-port networks. These are the main areas. There are some miscellaneous areas from which no question or very rarely question is asked, like coupling circuits. Okay, magnetic coupling circuits may not be asked questions from, but these are the primary areas in network analysis. And you know, in DC analysis, theorems are also covered. Theorems, don't think that theorems is not mentioned. I'm not treating theorems as a separate topic. I'm treating theorems as the subtopic of this DC analysis. There itself, see, in AC analysis, I'm going to discuss few points regarding AC theorems also. So theorems are applicable for DC as well as AC also. So in that itself, I'm going to discuss theorems, right? So why to wait? Let's enter into our topic, that is basics of network analysis, that is DC analysis. Let's start with DC analysis. Our topic is DC analysis. DC analysis, right? See, most of the students will commit mistake in simple things. See, hard things everyone will do, but simple things people are committing mistakes due to the lack of clarity. Okay, in DC analysis, before we enter into the problems, there are some areas must and should we learn first. That is the definitions like node, branch, principal node, simple node, mesh, loop, the relationship between branches, mesh equations, nodes, and all these things. Right? What is a node? Node simply means it is the point at which two elements or branches are connected. Very simple, connected, right? In network analysis or in electrical or electronics engineering, elements or branches means what? Resistances, inductances, capacitances, voltage sources, current sources, these things, right? Means, let me take one example. Okay, here the question is find the number of nodes yes, of the following circuit. Yes, this is the circuit I am taking. Yes, this is a circuit I am taking. Yes, yeah, let me put a DC only. Why to go up to AC now? This is voltage source. This is simply R1 I call, R2 I call, R3 I call, R4 I call, R5 I call, R6 I call. Right? Now, first of all, find number of branches. Branch is nothing but simply an element or source, whatever it is. One. It may be source. Source means what? Voltage source or current source. It may be an element like resistance or inductance, passive element like inductance or capacitance. Okay, or it may be dependent sources. It may be anything. That's an element. It may be diode. That's an element. Right? Number of branches are how many? See, the question is find the number of nodes and branches. How many number of branches it is having? Count. Yes, count the branches. Here. This is 1, this is 2, 3, 4, 5, 6. There are 7 branches. 7 branches or 7 elements. So, number of branches is equal to number of branches is equal to 7. That is equal to simply number of elements. Right? Now come here. We're done with the branches. Just you have to count the number of elements, including sources, everything. Right? Now what is node? It is a point at which more than one branch is connected. Right? What we wrote? It is a point at which two or more than 2 elements. It may be more than 2 also, na? At least 2 should be there. More than 2 elements or branches are connected. Now tell me, this is a node. Why is our voltage source, DC voltage source and resistance is connected? So this is node 1 I call, node 1. Right? Here, in fact, if you see 3 branches, R1, R2, R3 are connected, 3 branches. It may be anything. We are least bothered what it is. Right? So this is node 2. And here you see R2 is connected with R4. This is node 3. Here node 4. Yes, sorry. Here this is node 4. This is node 5, please. This is node 5 and this is node 6. There are total 6 nodes. Number of nodes is equal to how many? 6 nodes. Then I told something in the beginning, that is simple node, principal node, reference node, these things. What is a simple node? Simple node is a node at which only two branches are connected. Let me take the heading, simple node. See, in understandable words I am explaining you simple node. I am not going in depth, like if the degree of node is 2, then it is called as simple node. If the degree of the node is more than 2, it is called as a principal node. Degree of the node means the number of branches which are connected to that node. Number of branches connected to that node. Okay, simple node. See, this is the node at which this is the node at which only two branches are connected. Now let's identify the number of simple nodes here. Identify the number of simple nodes. This is a simple node. I call it as NS1. Yes, first node is a simple node, NS1. Now 2 is not a simple node. There are 3 branches connected, R1, R2, R3. 3 is a simple node, NS3 I call. 4 is a simple node. 5 is not a simple node, but 6 is a simple node. Observe it carefully, please, all of you. Yes, 1 is simple, 3 is simple, 4 is simple, okay, 6 is simple, but 2 and 5 are not simple nodes, right? Now, what is principal node? Okay, principal node. What is that? The node at which more than 2 elements are connected. More than 2 elements are connected. What are the principal nodes here? What are the principal nodes? This is, yes, this fellow is n principal node. This fellow is principal node. Right? We are done with node, branch, simple node and principal node. Right? Got the clarity? Then we have to see loop and mesh, individual loops. Okay, loop, individual loop, mesh, these things we have to see. And the relationship between I can say loops and meshes and branches, those things we have to take up. Okay, yes. Yeah, come here, all of you. Loop. A loop is any possible closed path. A loop is any possible closed path. It may be any, in any form. Okay, yeah. Let me take the same circuit or a different circuit also. No issues for us. Suppose this is 10 volts, 5 ohms, 10 ohms, 5 ohms. This is 5 volts. Observe this one. What is a closed path? What is a closed path? How to form a closed path? Closed path is the one if you start at a point and if you are ending at the same point. Yes. Starting and ending must be done at the same point, then that forms a closed path. See, I am starting here, okay, I go this way, I will come this way, yes, and I end here. This is loop 1. Yes, that is a closed path. Yes, that is one possible closed path. Second possible closed path is I start somewhere here, I start here, yes, this is a closed path. Second possible closed path, second loop this is. What I do is, I'll start somewhere over here, yes, this is my This entire total is loop 3. Total possible loops are 3. Don't think like this, sir. I start here, I go this way, again I end here, that is going to be new loop. No, that is same as that of loop 3. Okay, see, I'll tell you what do I mean. What do I mean by that? I'll tell you. The simple circuit I'm taking. How many loops it is having means only one loop. Don't think that, sir, I start here, I end this way, one loop. Sir, I start here, I end here, this is another loop. No. Why? Because a loop is said to be a new loop if you are touching at least one new element. If not, that is old loop only. Yeah. See, here in this red color, I rotated for one time, I got one loop. Again, you take a different starting point. You take a starting point here. Okay. But at the same red you are rotating, you are not touching any new branch. Okay, that is same old loop only. So how many loops are possible here? Number of possible loops is equal to, for this example, number of possible loops are how many? 3. For the above example, okay, I'm not generalizing it, it's not true for all the problems. Okay, some people will misunderstand. That's why I'm clarifying here. Okay, how many loops are possible? 3 possible loops. Then what is a mesh? And see, if you see loop 3, yes, if you see loop 3, loop 1 and loop 2 are the subsets of loop 3. Loop 1 and loop 2 are the subsets of loop 3. Means this loop, inside loop 3, loop 1 is there, loop 2 is there. Okay, why I'm talking about that concept of inside, you'll understand. What is mesh? Mesh M. Okay, it is a closed path. Yeah, it is a closed path. Sir, loop is also closed path. Then what is the difference between loop and mesh? It is a closed path in which no further closed path exists. Yes, means you have to select a closed loop in such a way that inside of that no further closed path should exist. So I'm giving one note statement here. Yes, all meshes are loops, but all loops are, I'll explain this, not meshes. All meshes are loops. Yeah, mesh is a closed path. What is a loop? Loop is a closed path, that's all. There is no separate definition, separate constraint for the formation of, just a closed path you must make. But what is a mesh? Mesh is also a closed path, means every mesh is a loop, but inside a mesh there should not be any further closed path. Now come here. See, loop 1 is there. I'm going with this blue color, you see. Inside of this, is there any further closed path? No. Loop 1 is a mesh. Loop 2 is also a mesh, but loop 3 is not a mesh, because inside the loop 3, loop 1 is there and loop 2 is there. So for this one, how many number of meshes are there? Number of meshes is equal to 2. Number of meshes is equal to 2. Yes. Now we saw these things, that is, we saw meshes, we saw branches, we saw nodes. Mesh, branch, nodes. Now there is a relationship between those three. What is that? Number of meshes is equal to number of total branches minus total number of nodes minus 1. This n is total number of nodes. What is that? Total number of nodes. Means either it is simple node or principal node or whatever it is, all nodes you must account. All those nodes you must take. Right? Now let us see whether this is a formula which is very important. On this formula, a number of competitive exams, number of times the question has been asked previously. Okay, come back. And let's see whether that is correct or not. How many, see for this one, how many meshes will exist? We know that this is one mesh, yes, mesh 1, this is mesh 2. It is having how many meshes? 2 meshes. So, sir, how we found the number of meshes? With inspection, identification with our eyes. I did not apply any formula. There is no formula for finding meshes directly for the meshes. By using that m is equal to b minus 1 plus 1, you can find that, but only with meshes, not using branches, nodes. There is no formula, right? With my eyes, I am able to observe that number of meshes is equal to 2, right? Now let us check whether the formula what we learned, that is equal to m is equal to b minus n plus 1 is correct or not. Yes. Now m is equal to b minus n plus 1. How many number of branches are there? 7 branches, you see. 7 branches minus. How many total number of nodes are there? Total number of nodes are 6. 7 minus 6 plus 1, that is 1 plus 1, that is equal to 2. So this one I got by direct inspection. This one I got with the formula m is equal to b minus n plus 1. M is equal to b minus n plus 1. Yes, that formula is correct. M is equal to b minus n plus 1. So these are the very basics which are required, and in fact we saw some 3-4 questions in this discussion, not just the concept, right? Now see, in entire network analysis, Ohm's law, okay, series connection, parallel connection, voltage division, current division, okay, these things are very important. KVL, KCL, KVL, KCL. Ohm's law plus KVL is mesh analysis. Ohm's law plus KCL is nodal analysis. Don't worry, okay, just I'm listing out what we are going to discuss. You need not remember all at a time, okay. So let's start with Ohm's law. Don't complicate it, okay. It is very simple. Ohm's law. What Ohm's law says? Simplified form of Ohm's law I am taking, that is, if there is any resistance units are R, resistance is represented with R and units are ohms. And there is a relationship between resistance and resistivity. R is equal to rho L by A. Rho is what? Resistivity. Its units are ohm meters, and the resistivity is going to depend on the material. Suppose if you take copper, its resistivity is different when compared to aluminum, okay. Resistivity is going to depend upon what? Is depending on what? Material, okay. Then L is length of the conductor you are taking for manufacturing resistance, length of the conductor, yes, in meters. A is, yes, area of cross section of the conductor, of whom? Of the conductor, yes, this is in meter square, okay, and its units are ohms, resistance units are ohms. Clear formula? See, every one of you know this formula. Yes, I know that you know this formula, but still why I am writing is, some people don't know the units of resistivity. Sometimes in some examinations the question is asked, if length of the conductor is doubled, then the resistivity of the material doesn't change. It is independent of length. Resistivity is not going to change if you double the length or half the cross section. What the hell you do with the conductor, resistivity is not going to change. It is the property of the material. It is what? The property of the material, right? For different materials, the resistivity is different, yes or not? So what Ohm's law says is, if you apply a voltage here, voltage is simply a driving force of the current, yes, it is going to drive the current, right? It is going to drive the current. If voltage is applied, voltage is the driving force, right? So it is going to drive the current into the resistance. See, you all are graduates in electrical or electronics engineering. Therefore, I am pre-assuming that you know what is voltage, what is current, what is resistance, and all these things, right? What Ohm's law says is the current that is flowing through a resistance is directly proportional to voltage. Means if the voltage increases, current will increase, and the current that is flowing through the resistance is inversely proportional to the magnitude of the resistance. If more is the resistance, current will decrease. So those two, if I combine in one equation, I am going to get I is equal to V by R, or V is equal to I into R, or R is equal to V by I. R is equal to V by I. So in three ways we can represent Ohm's law. That is simple. But all this is correct at constant temperature. Why? If temperature is changing, then obviously resistance value is going to change. See, materials are divided as positive temperature coefficient materials, negative temperature coefficient materials, right? For positive temperature coefficient materials, if temperature is rising, resistance will rise or increase. For negative temperature coefficient materials, if temperature is rising, resistance value will decrease. For example, semiconductors are negative temperature coefficient materials. Okay, metals are positive temperature coefficient materials. If temperature is rising, resistance will rise. That is Ohm's law. Means see, whenever you see resistance, voltage source, or resistance, current source, these kind of things, immediately one thing must get into your mind is that is Ohm's law, right? Then next thing is KCL, that is Kirchhoff's, yes, Kirchhoff's current law, Kirchhoff's current law, that is KCL. What this fellow Kirchhoff told is, further, we all know law of conservation of energy. In the same way, we have law of conservation of charge. According to law of conservation of charge, okay, I'll give you the definition of KCL, don't you worry. But before that, first of all, let's understand law of conservation of charge. According to law of conservation of charge neither be created nor be destroyed. Means how much charge is leaving, same amount of charge must return to the point. Okay, what do you mean by that, sir? Suppose there is something like this. Okay, I am not drawing the complete structure. Okay, now see here Q1 charge is coming, here Q2 charge is coming, then to this junction, yes, I forgot to tell you previously, node is also called as junction. Node is also called as junction, and that too, this is a principal node. At simple node, okay, let me talk about current division, node division, then I go for that. Okay, see, Q1 is coming, Q2 is coming, then suppose this is going Q3, if I say, then at the node A, according to law of conservation of charge, how much charge is coming, the same amount of charge must leave. No loss of charge or no gain of charge is going to happen. No loss, no gain. So how much charge is coming? Q1 plus Q2 is coming. This must be equal to the leaving charge. This is according to law of conservation of charge. According to what? Law of conservation of charge. Now, what KCL says, before to KCL, let's understand what is current. What is current? Current I is equal to the rate at which charge is moving with respect to time. Means charge is coming, but how much charge within how much time is coming or leaving, that rate of change of charge with respect to time is called as current. Okay, I is equal to dq by dt. Q, the units of Q is in coulombs, T is in seconds. The units are what? Coulomb per second. The units are what? Coulomb per second, right? So Q1 plus Q2 is equal to Q3. Q1 plus Q2 is equal to Q3. Now, see, what I do is, I can write it as dQ1 by, apply derivative with respect to time on both sides. Then what this will be? dQ2 by dt plus dQ3 by dt. Yes. So from this one, I1 plus I2 is equal to I3. This is nothing but KCL. Sum of the entering currents is equal to sum of the leaving currents. Yes, what KCL says? KCL says that, yes, what KCL says? KCL says that sum of all the entering currents is equal to, yes, KCL, sum of all the, yes, entering currents must be equal to sum of all the, yes, leaving currents. Sum of all the entering currents must be equal to sum of all the leaving currents. That is KCL. Okay, what is current? Rate of change of charge with respect to time. Right. Now let's understand KVL, Kirchhoff's voltage law. KVL. What KVL says to us is, yes, sum of all the voltages in a closed path must be equal to 0. Yes. KCL is derived from law of conservation of charge. KVL is derived from law of conservation of energy. Okay, I'll take up an example for this one, and a problem we are going to see. You need not to bother about it, but try to remember it. Then we can we'll understand. Once you remember, then we are going to execute it the same. Then you are going to remember. But first of all, try to remember. No worries, you remember. Okay, KVL is derived from yes, law of conservation of yes, energy. Yes, comma, KCL is derived from law of, yes, law of conservation of charge. Law of conservation of what? Charge. Okay, now let me take an example related to KVL. Okay, now plus minus, okay, here plus minus, here minus plus, this way I taken, this I am giving 10 volts, this I am giving 5 volts, and this I am giving X volts. The question is find X. Now very important technique we are going to learn here, which is going to be useful for us later. That's why 3 times I teach the same, 3 times. First of all, this is a closed path or not? Yes, this is a closed path. Immediately KVL must come into mind. Immediately, see, just like suppose if you go to a doctor, that fellow will check your pulse. Okay, check your pulse, and that fellow will take a step, he will put a step in his ears, then he is going to keep on your chest, on the back, because he is going to listen some basic things he will do, basic things he has to follow before he go for prescription or diagnosis, right? The same way, once you see this kind of circuit, immediately KVL or KCL should remember. One should remember. So if I see that, yes, I must remember KVL. Why, sir? He's asking about voltage. Now, what KVL says, sum of all the voltages in a closed path must be equal to 0. If you add all these 3 voltages, that must be equal to 0. I don't know one thing. So, one equation, one unknown, we can easily get, right? one equation, one unknown, I can easily get. Sir, then do one thing, 10 plus 5 plus x is equal to 0, correct? No, we should not do this way. We should not do this way. Why, sir? Voltages are having polarities. We should not add just like that. Those are not just numerical numbers, they have polarities. Current is going to have direction, left to right or right to left or up to down, down to up. Suppose direction means, suppose this is point A, this is point B. Current may be flowing from A to B or it may be flowing from B to A, right? So current is having direction, whereas voltage is having polarity. What is voltage? What is voltage? Yes, let me write here. See, this is the formula of voltage. Voltage is nothing but work done per unit charge. Yes, here current units, what I wrote, coulombs per second. It is also called as amperes. I forgot to mention over here, coulombs per second. Sometimes in the exam, in the question, he will give the units coulomb per second, but you will get wonder, oh, current unit should be amperes now, but coulombs per second, it is wrongly mentioned. No, coulombs per second and amperes both are same, right? Come here. Now see, work done is joules, Q is coulombs, joules per coulombs is the units of voltage, or simply it is volts. Simply it is volts. This is, or W by Q or dW by dQ, both are same. Being engineers, you know what does it mean by differentiation. Being engineers, you know that what does it mean by differentiation, right? Now sum of all the voltages in this closed path must be equals to 0. Yes, then how to add, sir? See, this is a closed path. Okay, why I am going this slowly here? Because this is very, very important, sometimes confusing. Simple, but some people will make it unnecessarily complicated. See, if you want to write a KVL equation of this closed path or loop or mesh, at some point you have to start. Sir, where I have to start? Your wish, my wish, or his wish, or his wish. Okay, so I want to start here. I want to start here. What I'm looking at? Minus, therefore minus 10. Yeah, I'm going. Yes, I saw plus, therefore it is plus 5. I'm going. Yes, I saw minus x must be equals to 0. Sir, why you did not came here? Yeah, if I come here, yes, again to the same point as that of starting, therefore done. Yes, minus 10, 2 more times I teach the same. Minus 10 plus 5 minus x is equal to 0. From this one, x is equal to what? Get this x this side, then you are going to left with minus 5 volts. Right, this is one way. Another way is, sir, I don't want to start over there. I don't believe you. So I want to start somewhere else. Okay, sir, I want to start here. Okay, this is a starting point. What you are encoding in the first place? Minus x. Why minus? Yes, this is minus x. Going forward, going. Yes, I saw 10, but with a minus. Yes, minus 10. Sir, I am going forward. Yes, I am seeing plus 5 is equal to 0. From this one, x is equal to, take x that side, how much it is? Minus 5 volts. Same. Someone will come and ask, sir, one time you started here, sir, why don't you start here? Why don't you go in the reverse direction? Yes, let me do that. Yes, I am starting here, I am going in this direction, no problem. Means if I start here, see, black color is the reference. Yeah, first I am able to see minus 5, going. Then I saw plus 10. Coming. Then this is plus, this is minus, this is plus. No, yes, plus x is equal to 0. Therefore, x is equal to 5 minus 10. So x is equals to minus 5 volts. In 3 ways we did the same problem. Simplest possible problem. Right? That is KVL. How to write a KVL equation? Basic KVL equation. Right? Now, KCL also we'll see. One example on KCL we'll see. See, all these are the basics. If you know the basics, then we will blast in, I can say, network theorems, or I can say in transient analysis, two-port networks. In these topics, very simply we are going to do once we know the basics. See, these networks basics not only useful in network analysis but also useful in control systems, in communication or in analog, especially theorems. Thevenin's theorem is very much useful in analog electronics. Always we find Thevenin's equivalent impedance or resistance in analog electronics. Okay, come here. So come here, first of all let's count the number of nodes. Number of nodes we count first. Let's make it practice. This is node 1. This is also same node. This is also same node. Why? Here to here no element. Here to here no element. So this total is one node. This total is one node. Totally there are only two nodes. Don't think that, sir, this is one node, this is one node. Node is the place at which more than one branch is connected. Right? Two or more than two branches are connected. More than one means two. Two or more than two are connected. Right? So this is node. Okay. Now this is, suppose say this is 10 amperes. This is 5 amperes. I want, this is 5 ohms. I want to find current I in this. Current I in this. Right? KCL. What KCL says? Sum of all the currents entering at a node must be equal to sum of all the currents leaving the node. Come here. 10 amperes is coming. 10 is coming from here. See, at this node, let's take node A. Node number in, naming as A. KCL at node A. What KCL says? 10 amperes is coming. These are the coming currents. This I is leaving. 5 is also leaving. So coming currents is equal to leaving currents. What are the leaving currents? I plus 5. So from this one, I is equal to 10 minus 5. It is 5 amperes. Right? Done. Yeah, KCL is damn easy. Sum of the, see, incoming current is 10, or this way also you can take. Sum of all the incoming plus outgoing currents is equal to 0, but incoming is positive, then outgoing should be negative. Yeah. When you see, this way also we can write. Incoming is 10. As it is outgoing, I write it as minus, equal to 0. Sum of all the currents at a node or junction must be equal to 0. That is also KCL. Sum of all the currents at a node or junction must be equal to 0. That is also KCL. Right? Then, see, we'll go for some questions. We go for some questions. Read the first question, please. Which one of the following represents a single element such as voltage source or a resistor branch? One element is what? It may be voltage source, it may be resistor, it may be inductor, it may be capacitor, it may be dependent source, it may be BJT, it may be diode. Whatever it is called as one branch. Yes, answer is branch. It is not, yes, it is not a node. Node is a point at which more than one branch is meeting. We have simple nodes and principal nodes. Loop, it is a closed path. What is a closed path? Where you start, again you have to end there only. Circuit, yeah. What is the difference between circuit and a network? If closed path is existing, that is circuit. If no closed path, that is network. Okay, see. What do I mean by that? This is a circuit. Yes, why? Closed path is there. Now, you see. This is simply network. No closed path. All circuits are networks, but all networks are not circuits. Connection of elements in any manner is called as network. Connection of elements in such a way that closed path is formed, that is called as circuit. All circuits are networks, but all networks are not circuits. I am not writing that point. I hope you understood the point. Or let me give a note point here. All circuits are networks, but all networks are not circuits. right? Yes or not? Yes. Now see, yeah, see, the nodal method of circuit analysis is based on, yeah, see, we had to enter into nodal and mesh. Nodal and mesh we had to enter. Let me explain that nodal and mesh. Let me explain, then we go for the remaining questions. Okay, because the basic questions start from nodal and mesh. The basic questions will start from nodal and mesh. Without nodal mesh, yes, it is not possible to solve even a single network also. Nodal analysis, yes, what is that? Nodal analysis. Nodal analysis is nothing but, see, at a node we write equations. What equations? KCL equations. At nodes, KCL equations are written to solve a problem. Then it is called as nodal analysis. Nodal analysis. See, let me take up one problem, then you will understand. Okay, example problem I am taking. Though these are named as examples, but these are the questions previously asked in number of competitive examinations, right? Let's solve this problem. Okay, so let's take this one as 10 volts, this one as 5 volts, this one as 5 ohms, this one as some 2.5 ohms. Let's take this one as some 5 ohms. Okay, first of all, number of nodes. How many number of nodes are there? Simple nodes we have to count, means all nodes, not simple nodes, sorry, all nodes we have to count. This is node 1, node 2, node 3, yes, this is node 4. Total nodes are 4. But remember one thing, when we are writing KCL equations or in nodal analysis, we have to write the equation only at the principal nodes. Why? Tell me, at this node is there any current division taking place? No. Sir, how can you say, sir? Some amperes, some current is coming from here. The same current will go into 5 ohms. There is no other element to share that current, right? So no current is getting divided, therefore no KCL to write. Suppose if this is I, this is also I is equal to I, nothing we get. Yes, nothing we get. Come here. Here also no KCL, but here I can write KCL, right? And this is also, sir, principal node. Na? One of the principal node can be taken as a reference while writing, while doing nodal analysis. Yes, let me write here. In nodal analysis, one of the principal node, you can take simple node also, no problem. One of the node is taken as reference, and KCL equations are written. KCL equations are written only at principal nodes, not at the simple nodes. Nothing to write at simple nodes, man. Yes. So now tell me, this is a simple node, need not to write. This is a simple node, need not to write. This is a principal node, but it is taken as reference, means we need not to write at the reference node also. I am left with only one node. Here I have to write the KCL. Here I have to write the KCL. Sir, First of all, what we have to find, sir, lot many things we can find. Lot many things we can find. I want a current in this branch, I. I want a current in this branch, I1 I call. I want a current in this branch, I2 I call. I want those. Okay, find, the question is find I comma I1 comma I2. Right, now how to find, sir? See, first of all, let's break the problem into small pieces. That is, I want this current I. If I want current in a resistance, what I must know? Current is equal to voltage divided by resistance. I must know the voltage and resistance. Resistance is happily available 5 ohms. Voltage I don't know. Therefore, I assume this voltage as V, capital V. I assume the voltage as capital V. Okay, now let's write KCL over there. According to KCL, sum of all the incoming currents is equal to sum of all the outgoing currents. Now come on, what is the incoming current? I1. What is another incoming current? I2. What is the outgoing current? Small I. I1 is incoming, I2 is also incoming, I is leaving. Right? Now, what is I1, sir? I1 is the current. See, this voltage is at 10, this voltage is V. Then see, suppose here, observe carefully, this is a crucial point. This is some 5 ohms. Here the voltage is 10 volt. Here the voltage is 5 volts. What is the net voltage that is getting appeared across this 5 ohms is 5 volts only. Why, sir? See, that simply, in simple language we can start. You are holding here, somebody is holding here. He is pulling, he is also pulling. What is the net force on this one? This force minus this force now, or this force minus this force. At two ends, if two different forces are acting, then the net force will be the subtraction of those two forces. Same way, yes, same way. Come here, I am writing. What is I1? Yes, I1 direction I taken this way means current is flowing from this one. Therefore, 10 minus, what is the voltage here? This is the resistance. At this end I have V, 10 volt. At this end I have V, 10 minus V by 5. I1 is 10 minus V by 5. Then what is I2, sir? I2. This is I2. This is I2. I taken this direction. Therefore, this is from here it is coming. Therefore, this is the high voltage 5 minus. What is the force here? V. Force means voltage by 2.5. Yes, I got I2. Then what is small I? Small I is the current here. At this end, yes, current is flowing this way means this is the high value, this is the low voltage. So high voltage minus low voltage divided by 5. So I is equal to V by 5. Substitute all these. This and this in this. What is that? I1 plus I2. 10 minus V by 5 is equal to, yes, 10 minus, let me go with the different color. Yes, 10 minus V by 5 plus 5 minus V by 2.5 is equals to V by, yes, it is 5. Check any calculation mistake. 10 minus V by 5, yes, 5 minus V by 2.5, yes, it is 5 minus V by 2.5 is equals to, yes, V by 5. So solve for V. How much I get? 2 minus V by 5 plus 2 minus V by 2.5 is equals to V by 5. What I do is 2 is 4 minus V by 5. This V by 2.5 I can write it as 2V by 5 is equal to V by 5. So 4 is equals to V by 5, that side it is already there. This minus V by 5 will be plus V by 5 plus this will be 2V by 5, 2, 3, 4. So 4V by 5 is equal to 4, 4 gone, V is equal to 5 volts. See, for your explanation and understanding purpose I am going this slowly. Don't think that, sir, for simple problem we are taking this much time. I am explaining you guys, that's why it is taking this much time. Otherwise one equation is enough for us, one equation. Okay, yeah, in the later problems, in the later classes, you will be understanding how one equation is sufficient to do that problem, right? So I got V. If V I got, what is this I? I is equal to, what is that? V by 5. How much is V? Is 5 by 5. How much that is, man? 1 ampere. Simply the current is 1 ampere. So this is what nodal analysis. How many nodal equations are required to solve a problem? Yes, how many equations we wrote for this one? First of all, let me take the same problem to give one conclusion. Okay. So conclusion is very, very important. Okay, come here. See, this is some 5 ohms I taken. Okay, values are not much important for us here because conclusion is important, structure is important for us here. Yes, this is also 5 ohms. This is I taken it as 2.5 ohms, and this voltage I taken it as 5 volts, right? How many principal nodes are there? This is NP1 and this is NP2, and this is taken as a reference. In fact, how many equations we wrote? Only one equation. We solved this one. Don't think that sir, this is one equation, this is one equation, this is one. No. This equation only I solved this way, simply for your understanding sake, right? So how many equations are required for this particular network to solve with help of nodal one equation, right? So here, number of principal nodes is equals to 2. Number of, yes, I name this one as NP. Number of principal nodes, I am naming it as NP. Number of nodal equations to solve the network, to solve the circuit. How many required here? Only one. Now can I write? I am generalizing this one. Number of nodal equations required to solve a network, to solve a circuit, to solve a circuit is equal to number of principal nodes minus 1. Yes, this kind of theory questions for sure will be asked in your exam. Yes, how many? NP minus 1, number of principal. First, see, one question will be given and he will ask nodal require how many equations, mesh require how many equations, which of the among nodal and mesh which is the best method? Simple. Number of nodal equations are NP minus 1. Number of mesh equations we are going to see. Our heading is next mesh analysis. Our next heading is mesh analysis only. Okay, yeah, come here. Mesh analysis. See, nodal analysis is what? KCL plus Ohm's law. Nodal is KCL plus Ohm's law. Why, sir? Yeah, this is KCL, no? Sum of the incoming currents is equal to outgoing current. Sum of the incoming currents I1 plus I2 is equal to I. That is KCL. But how I found this current I? By using Ohm's law. Current is equal to voltage divided by resistance, right? So nodal analysis is KCL plus Ohm's law. This is also one of the question. Don't think that it is theory. Okay, yeah, in further questions, in previous questions you can find that question. Okay, direct answer. Next is we are in mesh analysis. Mesh analysis is KVL plus Ohm's law. So this is what? KVL plus Ohm's law. Same previous problem. Yes, let us solve with the help of KVL. How many mesh equations I have to write? Equal to M, where M is equal to what? B minus N plus 1. Yes, previously I shown to you, I proved that one to you. Okay, yes, this is the current I want. Here also the same current I want. I have to see whether the same value I am getting or not. Either mesh analysis or nodal analysis, answer must remain same. See, you are doing one problem, same problem I am also doing, but you are doing with help of computer, I am doing with help of calculator, somebody else is doing orally. Does it mean all three answers should be different? No, no, all three answers must be same, then only all our three methods are correct. Come here. Now, mesh analysis. This is one mesh, the direction of the mesh. In the mesh, there is some current flowing I1. I assume it as I1. Here, I assume the current this way. Sir, why you are assuming that way only? One is clock, another one is anti-clock. My wish. If you want, you can take both in clock. If you want, you can take both in anti-clock. One clock, one anti-clock, anti-clock clock. Your wish. I told you, when you are writing KVL, that is your wish. KCL also, incoming currents is equal to outgoing currents. Outgoing currents is equal to incoming currents. Outgoing plus incoming is equal to 0. If you are taking outgoing as positive, incoming should be negative. If you are taking incoming as positive, outgoing should be positive. This way, anyway you can take. Right, this is I1. Now tell me, at here if I write KCL, I1 is coming, I2 is also coming. Now can I write I is equal to what? I1 plus I2. I is equal to what? I1 plus I2. And one note point I want to give here, that is current entering terminal must be taken as positive. Current, yes, entering terminal. Current entering terminal is taken as positive for RLC elements. For RLC elements, current entering terminal must be taken as positive. Now see here. Therefore, what do I mean? So this will become plus, this will become minus. Here I is entering here, this is plus, this is minus. Here I2 is entering here, this is plus, this is minus. Now, what is the voltage drop across this 5 ohm? I1 into 5. What is the voltage drop across this 2.5? I2 into 2.5. What is the voltage that is dropping in this 5 ohms? 5 into I, but that I is equal to I1 plus I2. So, KVL for mesh 1. KVL for mesh 1 I am writing. I am starting at this here. So, minus 10 plus 5I1. Yes, plus, yeah, this way I am going, I am coming, I am completing this way. Yes, plus 5 into I is what? I1 plus I2, that is equal to 0. 5I1 plus 5I1, 10I1 plus 5I2 is equal to, yes, 10I1 plus 5I2 is equals to 10I1 plus 5I2 is equal to 10. Is equal to 10. This is equation 1. Now let's write KVL for loop 2. See, mesh 2. Sorry, KVL for mesh 2. Sir, wherever you want to start, previously 3 times the same thing I taught to you. That's why I am not going in another way. Okay, you can try. Okay, I'll start at minus 5. What I get? Minus 5. Yes. Let me complete this way. Minus 5 plus I2 into 5. Plus I2 into 5 is nothing but 5I2 plus 5 into small I must be equal to 0. Sum of all the voltages in a closed path must be equals to 0. So 5I2 plus 5I is equal to, yes, 5I2 plus 5I is equal to, yes, what it is? 5 is equal to 5, but 5I2 plus 5I is what? I1 plus I2 is equals to 5. So this is 5I1 plus 10I2 is equal to 5. This is equation 2. If we solve these two equations, we get I1 and I2. Yes, 10I1 plus 5I2 is equal to 10. Then this is 5I1, multiply with 2 here. Then what happens is 10I1, I am multiplying this equation with 2 on both the sides. Total equation So what is this one? 20I2 is equal to 10. If I add 10 gone, how much it is? 25I2 is equal to 20. From this one, I2 is equal to what? I2 is equal to what, ma? 20 divided by 25. Let's keep it as it is, amperes. Now I want to get I1. Put that one here. Yes, I am doing here. 10I1 is equal to 10 minus 5I2. 20 divided by 25. 5 5s it is, 5 4s it is. So 10I1 is equal to 10 minus 4, it is 6. So I1 is equal to 6 by 10, right? So this way we got I1 and I2, right? So this is the mesh analysis. Now tell me, how many mesh equations we wrote? How many mesh equations we wrote? This is the first equation. This is the second equation. Same problem, if we want to solve, two mesh equations are required. But how many nodal equations are required? One equation. For this given problem, which method is the best method? Nodal method. One equation is enough. Here two equations are required. Which is easy to solve? One equation or two equations? Two equations. Time consuming, right? See, this way we will learn, okay, all the concepts. We are done with the basic Ohm's law, node, simple node, principal node, mesh, loop. I told you one more point, individual loop. Meshes are also called as individual loops. Okay, I forgot to mention over there, meshes are also called as individual loops. Okay, KVL, KCL, Ohm's law, okay, nodal and mesh. Every problem, see, problems, questions asked are simple only, but in topics like theorems, Thevenin's equivalent resistances, maximum power, numerical questions are given in the previous papers, right? So join your hands with YourPedia to accelerate your preparation towards BEL examination, right? All the best and thank you.